At an initial velocity of 500 feet per second, a body is dropped from 1,000 feet in the air. With no air resistance assumed, identify the time required for the body to hit the ground. So in this video, this is actually a random differential equation problem. When you say differential equation, it's basically the combination of derivatives and antiderivatives, or in other words, integration, right? And if you're asking me, can we solve this without the use of calculus? Well, to answer that question, yes. You need high school physics, right? Like if you learn in your high school physics, you will know what would be the procedure here in terms of solving this problem. But for the sake of this video, I'm not going to do that. Rather, I'm going to do a way on how I'm going to solve it based from the topic differential equation. Okay, so basically, I'm not going to use a formula I've learned in high school physics. Instead, I'm going to do how I'll be solving a problem related in the topic about differential equation. So, how are we going to do this one? Okay, so here's what we're going to do. Okay, first and foremost, okay, the first step here is that there are two ways to solve this problem. And these two ways, it depends on your sign convention. Okay, it depends on your sign convention. Why? Why are we going to relate the sign convention to this problem? You see, this sign convention tells you which direction is positive and which direction is negative, right? So, what do you call this one? We learn in our high school physics that what goes to the right and upward, or both, they are both positive. The opposites will be negative. All right. So that means left is negative, down is negative. All right. Now, you see, this is the usual way on how we are taught in high school in terms of, yeah, motion, especially in vectors. Yeah. Now, here's the thing. Okay. In here, we can use the first way. The first way here is that assume that whatever goes up is positive and whatever goes down is negative. That's the first way. Another way is, what if we make it reverse? Like instead of making up positive, down negative, what if we make downward positive and upward negative? All right? It's still valid. Okay? It's up to you if that's what you want. All right? It's clearly up to you. So in this, for the sake of this video, I'll try my best to compress these two ways of solving it, depending on your sign convention, in this video. Okay, so basically, let's try solving this one with first way, then later let's try the second way. Right? So the first way is assume that whatever goes down will have a negative result or negative value, and whatever goes up is positive. Okay? So that is our first way. Okay? First, uh, yeah, first way, basically. First way, upward, positive, downward, negative. Okay. So that's it. All right. Second thing here is that here, what I call this one, you have to know your acceleration first. In fact, that's the first step. Getting to know your acceleration. What is your acceleration? That's your first step. Now, you see, if you're asking me, how are you going to find the acceleration here in this problem? Because the acceleration here is not given. It is not visibly given, but it's indirectly given, meaning it's already there. It's just that we didn't see it. Because you see, this is an example of free fall motion. If ever the scenario is about you're throwing a ball upward, what happens? You know, what happens if you throw a ball upward? It will go up, but then once it reaches its maximum height, it will go down afterwards, right? That's also the same thing, like if you're going to drop an object. Like for example, I have a TV remote, okay? If I'm going to drop it down, what will happen? It will go down, right? So, what examples I showed to you right now are example of free fall motion. Okay, in that case, the acceleration here is due to your gravity because gravity is the reason why whatever comes up will go down. Okay? So there's a saying, whatever comes up must come down, right? Gravity is the reason for that. Gravity is the reason why we are being pulled downward. Gravity is the reason why if I have a TV remote and I'll drop it down, it will go down because of the gravity. In fact, you see, to give you a scenario, if you drop an object here at this part, it will slowly increase the speed of the body falling down. Okay? Like this distance is just short. I mean, the positions of these two are just, smaller. Then sooner or later, it becomes larger, becomes larger, becomes larger. All right? Because as time goes by, and then in the process of falling an object or a body, the speed of the falling of the body increases, and that is because of gravity. And now you see there are values for your gravity, but the two common values are 32 feet per second squared and 9.81 meters per second squared. So there are two common values for that. The question is, which one would you pick? Now, the best way is to look at your given. So the given, you have an initial velocity of 500 feet per second. That's one. And then here, initially your body is from 1,000 feet. So if you're going to observe, you have feet, you have second, you have feet. So that means you're not going to use this, okay? You're not going to use that. Rather, you're going to use feet per second squared because the unit has a feet and a second. So therefore, we're going to use this one instead. But what if you prefer 9.81 meters per second squared? If that is what you want, then you must convert the feet into meters if you wish to use 9.81 meters per second squared, okay? And remember, gravity is pulling us downward. And remember, in first way, in solving it, whatever comes up is positive and whatever comes down is negative. Hence, I will have negative 32 feet per second squared. Okay. So with that, okay, we know our acceleration. So what's the next step? Okay. The next step here is that you're going to change your A into dv all over dt. Okay. Why? Why is it that we did change that? Okay. Let's take a look again at the problem. You want to find the time required for the body to hit the ground, right? You want that. Now, here's the problem. If you want to find the time required for the body to hit the ground, you need a wait. Yeah, you need a displacement formula. Okay, you need a displacement formula. Okay, you need that. The problem here is that we don't have a displacement formula. So, how are we going to find a displacement formula? Now, that is actually what we're going to do. We must find first the displacement formula before we answer this problem. Before we answer this problem, we must find this one. The question is, how? Okay. Remember, right, we change A into dv all over dt, okay? Because you see, acceleration is just the same as the derivative of your velocity, which is your v, by the way. Your v is velocity with respect to time, which makes sense because you see, acceleration is rate of change of velocity. You get me? So therefore, your acceleration can be changed into dv all over dt or the derivative of v with respect to t. Okay? Now, our goal here is that in here, we need to find your, what do you call this one? You need to find your velocity formula. Okay? We need to find that. Okay? In here, you see this? We need to find your velocity formula. Why? Why do we need to find the velocity formula when we actually need is displacement formula, right? So why find velocity formula when we're looking for displacement formula? Well, it is because that your velocity, okay, assume that you found already the formula of your velocity. Because velocity is the derivative of your displacement with respect to time. Your v is just the same as ds all over dt. So, once you found the formula for your velocity, we can change that v as ds all over dt and find the s, okay? Because your s is your displacement. All right. So I think you get the steps. Okay. So first, get to know your acceleration. Next, change it to dv all over dt, which is like this. Then next, find the velocity formula. Okay. Before we change the v into ds all over dt. So this is the step that we're going to do. Find the velocity formula. The question is how? So here we can apply a method in solving this type of equation by separable variable. Okay, basically, uh, you see this dv. If you see a variable that is at most at v variable, group them together with dv. Likewise, for dt, if you see any term that are at most a t variable, group them together with dt. So in this case, what I can do here is I will just basically put dt beside negative 32, okay? So I will have dv is equal to negative 32. Let me just disregard the unit here, okay? 32 dt, okay? Here, with that, what I call this one, yeah, I basically group dt with negative 32. And in this case, I can integrate them both sides. Okay, because if you're going to integrate both sides, make sure that it corresponds to the letters beside the d, which is why it's called separable variable. Any terms that are at most a v variable, you're going to group it here. So constant term, v variable, put it on dv. Similarly, on dt, if you see constant term, or t variable or both, you put it here so that we can integrate them. So in this case, we can integrate them both sides, all right? So how to integrate these two? If you see this one, this is just the same as the integral of 1 with respect to v, okay? So you see both of the variables have constant terms, okay? 1 and negative 32. So let's have a recall. Recall that if you're going to get the integral of a constant with respect to a given independent variable, all you need to do is just put the independent variable beside the constant. That's it. Like that's it. So, oh yeah, by the way, plus c, of course. Don't forget to put plus c. So therefore, if I have 1, so since I have dv here, so the integral of 1 with respect to v is just v. Okay? Then here for negative 32, it's a constant term, and you're going to integrate with respect to t. So I will have negative 32t. That's it. Then plus c. Now, here's the thing. Right? I integrate both sides. So therefore, shouldn't I have also plus c as well on the v? To answer that question, no. You should only have 1 plus c. It depends. If you want to put it on the left, sure. Put it on the right, sure. But both, nope. It should be only one side, okay? There's like a detailed explanation for that, but for the sake of this video, I'm not going to explain a lot, right? So I decided to put plus c on the right. Now, here's the thing. In here, it seems like we found the v formula, right? But this is actually a general solution, okay? Why is it called a general solution? Because you see, right, we have plus c. This plus c, which is actually known as a constant of integration, it's actually an arbitrary constant. you have a general solution when the arbitrary constant is not given with a specific value. So meaning we need to find what's the value of your C. Okay, this is an arbitrary constant. We need to find the value of C. We need to do that. Now, the question is how? Now, we're going to relate it in a what? In a initial condition. Okay? So, in an initial, no wait, not initial condition, in initial scenario. Okay? Initial scenario. Like in the beginning of the scenario. Okay? So, in the initial scenario, of course, when, what goes one? When you say initial scenario, the ball is not yet dropped, right? So, that happens at t at 0 seconds. Because basically, initially, like at the very, very beginning, your time should be 0 seconds. Okay? That's the time where like the ball is not yet dropped. Okay, it's not yet dropped. Next here, we have an initial velocity which is 500 feet per second. Now, here's a question. Okay. Okay, yes, your velocity is 500 feet per second. But the question is it positive or negative? Well, according to the given, it's positive. So I'll just put positive, put positive 500 feet per second. No, it's not positive. Why? Look at the problem carefully. Okay. Yes, you have an initial velocity of 500 feet per second. Okay, 500 feet per second. And here's the thing. The body is dropped, dropped. It's not thrown upward, it's dropped. What happens when the body is dropped? It will go down. Hence, your initial velocity should be also in negative sign as well because it goes down as well. Okay, so be careful with the problem. All right. So whatever goes down, again, remember, we are on the first way. The first way is what comes up is positive, what comes down is negative. So initially, okay, yeah, the ball is going to drop, right? So of course, where it will go? Down. So it should be negative, okay? So now with that, we will substitute our t and v in our general solution. So here, we will have, what's that again? Negative 500 feet per second. Let me just disregard the unit. Is equal to negative 32 times 0 plus c. Negative 32 times 0 is just 0. So 0 plus c is just c. So therefore, your C, which is your arbitrary constant, is negative 500. So therefore, you have V as, let me just copy, negative 32t. Then your C is negative 500. Now you see, the C is given. You can now say that this is a particular solution. You will know if it's a particular solution when your arbitrary constant, or in this case, your plus C, had a given uh, number or value. So that's it. This is now the formula of your velocity. Now, with that being said, we can now proceed to the next step. Just like what we did to the velocity for acceleration, we change it to dv all over dt. So we will do the same thing for v. We will change v into ds all over dt. Let me put it here. Okay. So change it into ds all over dt. Okay, which makes sense because why? Velocity is rate of change of displacement. Okay, or another way to say it in calculus term, velocity is the derivative of displacement with respect to time. Okay, and what next? Then you solve for your s. Okay, or solve this equation basically. Okay, let's solve it so that we can find the s. So here I will do the same thing. I will do separable variable method. Group all the terms, either constant term, s, it has a s variable, or both, into ds and group all the constant terms, t variable, or both to dt. So what I will do is I'm going to put dt beside here. So I will have ds is equal to quantity negative 32t minus 500 dt. So in this case, you see um, in here on the right, you have a t variable and then you have a constant term. Okay, and on the left side, I have ds, but remember, this is just the same as what? 1 ds, right? So in this case, I can now integrate both sides. So here, the integral of 1 with respect to s. So here, I'll just apply a constant rule of integration. So I will just have s is equal to this one here. If you see a variable here, you're going to apply the power rule of integration. Okay. So here, if you have a variable, okay, if you have a variable and then it has an exponent given, okay, where the exponent should not be equal to -1, the answer for that is x raised to n plus 1 all over n plus 1 plus c. All right. And also, if you have like a constant term beside a function, okay, and you're going to integrate it, that means you're not going to you can just bring out the constant to the left, or you can bring it out. So you will have constant times the integral of f of x. Okay. So we're going to apply these two rules here. Okay. Why? Because you see, if you're asking me for the integral of negative 32t minus 500, this is just basically another way of saying the integral of negative 32t dt minus the integral of 500 dt. Okay? And you see, we have a constant of negative 32 and we have a variable of t. So we can bring out negative 32 outside. So I will have negative 32 times the integral of t. And that's it. Now, here's the thing. T is just the same as t raised to 1. Okay? It's actually according to identity property of equality, I guess. X is just the same as x raised to 1. 1 is just the same as 1 raised to 1. Therefore, t is just the same as t raised to 1. Right? So here we're going to apply power rule of integration. So therefore, okay, you will have negative 32 times t raised to 1 plus 1 all over 1 plus 1 minus, for here, 500. It's a constant term. So the integral for constant term, just put a variable. So we will have minus 500 t. Then, of course, don't forget, plus c. Okay, don't forget. Okay, so we will have negative 32 times t squared all over 2 minus 500 t plus c. We can simplify the first term because on the first term, we have negative 32 times t squared all over 2. You see, negative 32 and 2 are both divisible by 2. 2 divided by 2, wait, 2 divided by 2 is 1, and negative 32 divided by 2 is negative 16. Hence, your simplified answer would be s is equal to, wait, hold on. s is S is equal to negative 16 t squared minus 500 t plus c. But again, guys, you see, this is not a formula for what? For displacement yet. Because you see, this is just a general solution. So meaning, guys, we need to find your C so that it will become a particular solution. And that would be the formula we are going to use. So how to find it? You will start at the initial case or initial scenario, basically at the very beginning of the scenario. So of course, at the very beginning of your scenario, your t is 0 seconds, okay? At the very beginning. Now, what is your s? Or the displacement, initially speaking? So basically here, um, right? The body, wait, assume the body is just a ball, okay? Right? You're going to drop it in which it reaches 1,000 feet, right? It will reach 1,000 feet if you're going to drop it. Now, when you say initial, meaning here, okay, here, okay, it meant here, at that part. So, does the body achieve a distance? Like, for example, at the very beginning, does your body achieve like, let's just say it achieve, let's just say 200 feet, okay? Initially, the ball achieved 200 feet. Then, after 0 seconds, it will go down and then it reaches additional of 1,000 feet. So, does it happen that way? Okay, in our problem, the answer is no. Because you see, you're at the very beginning. You are here. You are here. I mean, the body is here. So it doesn't achieve a distance or displacement yet. Not yet. It's just like, for example, I am here, right? Okay, and then I'm going to move there. That's my position here, like the destination. Okay. Initially, of course, my time is 0 seconds. Okay. Then let's just say I move here and then it took me like 3 seconds. Okay. So in here, okay, between this position and this position, I can get what? The distance here. But here's the thing, okay? I am right here at the beginning. So have I achieved any distance or displacement? No, because I am still there at the resting position or stationary position. I haven't achieved any displacement yet. So therefore, it's zero. Okay, it's zero. So now we will substitute it here, okay, in this general solution. So you will have s as 0 is equal to negative 16 times 0 squared minus 500 times 0 plus c. All of them will result to 0. Negative 16, 0 squared, 0 minus 500 times 0, 0. So 0 plus 0, negative 0 minus 0 plus c is just c. So therefore your c is 0. Hence, your particular solution would be this, okay? Would be this one. Since your C is 0, of course you're going to put plus 0 here. But since you have plus 0 here, you can just simply disregard plus 0, like remove it, and leave it that way. So here, this is not a general solution anymore, but rather a particular solution. Oh, that's it. Now that you have a particular solution, what's the next step? You can now use this formula to solve the problem. What's the problem? So according here, okay, we found the displacement formula. Okay, we're good. Now here, identify the time required for the body to hit the ground. So basically, wait, hold on. So basically, okay, let's proceed here. Okay, let's proceed here. Basically, okay, the body is here, right? And then suppose it's dropped. Okay, when it's dropped, it's 1,000 feet. Right? It's 1,000 feet. Now, how long will it take to reach 1,000 feet? Like basically, how long does this body will achieve falling to the ground? All right, in which it achieves 1,000 feet. All right, so we're looking for a time here when you're what was one when you reach to the ground. All right. So with that being said, then that means our S is 1,000 feet so that we can find the T here. Is it 1,000 feet? Yes, but negative. Your S here would be negative 1,000 feet. Why? Why is it that your displacement, uh, yeah, correct. Your displacement, which is 1,000 feet, is negative? Because you're still going down, right? Again, the body drops. You're going down, right? So therefore, your S would be what? 1,000 feet. Okay? You're going to substitute your S as negative 1,000 feet. Then here, we can now find the time. Okay, here we can now find the time. All right? So here, in this case, if you're going to observe, you have t squared, you have t. So in here, I think it has something to do with solving a trinomial. Okay, because you see, in here, if you see a second degree or basically exponent that has squared, and then next term you have t, which is basically first degree, but uh, first degree or your exponent is only one, that means what do you call this one? That means you're going to solve a what goes one a given trinomial. Okay, why is it called trinomial? Because for trinomial, it's like this: ax squared plus bx plus c is equal to 0. This is a trinomial. You have three terms: the squared, the x, and the constant term. So it's related here actually. Okay. So what I'm going to do is bring 1,000 to the right. So as a result, I'll be having negative 1,000. Sorry. Wait. 0 is equal to negative 16 t squared minus 500 t plus 1,000. That's it. Okay. Now you see it is in fact a trinomial because you will know it's a trinomial when you see squared and a t. And then suddenly you have a constant term. So squared variable and then constant term, combine them together, boom, you've already formed a trinomial. So therefore, if you're going to solve a trinomial, there are three ways. Either you factor, two, you do complete the square, or three, quadratic formula, which is the backup plan. So for me, I'm going to use quadratic formula, okay, to solve the time here, okay, to solve the time here. Because for me, that's the backup plan. So remember, the formula of your quadratic formula is what? Negative b plus minus the square root of b squared minus 4ac all over 2a. Okay. So if you're asking me what's a, b, and c, basically, think of it this way, like that. Okay. Your a is just beside the squared. Your b is just beside the variable. That's the exponent of 1. I mean, in which the exponent is 1. And your c is just a constant term. Therefore, your a here is 16. Your b here is negative 500. And your c is 1,000. So you're going to substitute it here. Okay, so you have negative b. So that's negative 500 plus minus a square root of negative 500 squared minus 4 times your a, which is negative 16, times your c, which is 1,000. Okay, all over 2 times your a, which is negative 16. Okay, let me just combine everything, okay? Negative times negative 500 is 500 plus the square root of. Okay, let me just use my calculator for a second. Let me just combine the inside of the roots. Okay, so let me just pause this one for a while. It's 314,000. Okay, 314,000 all over 2 times negative 16. It's negative 32. Let me take a look if I can simplify the root here one more time. According to my calculator, square root of 314,000. Wait, yeah, 340,000 is just the same as 20 times the square root of 785 all over negative 32. I can simplify this one because I believe that 500, 20, and 32 are all divisible by 4. Okay, so that means 500 divided by 4 is 125. 20 divided by 4 is 5, and negative 32 divided by 4 is negative 8. So therefore, I will have 125 plus minus 5 square root of 785 all over negative 8. And we can simplify this one more time by putting the negative sign of 8 beside the fraction. So that means I will have negative 125 plus minus 5, the square root of 785 all over 8. So notice that you have plus minus. So that means you have two values for your time. One, it's in plus instead of minus. Okay. So that means you will have instead of minus or instead of minus, you will have plus, or instead of plus, you will get minus. Okay. So minus 5 square root of 785. Okay. So the question is, are they all correct? Not really. One of them should be correct. How though? How do we know if one of them is correct? If they have a positive answer. All right? Let's take a look. Which one of them has a positive answer? For the first t value where you have 125 plus 5 square root of 785, you get approximately negative 33.14 seconds, which is wrong. We're not going to use this. Okay? Now let's take a look for the second value or the second value for time. This is approximately 1.89 seconds. Since your second value is positive, then this is your final answer. That's it. That's your final answer. The time required for the body to hit the ground is 1.89 seconds. That's fast actually. It's just like, approximately 2 seconds. Now, if you're asking me why not negative, because there's no such thing as negative seconds. Like for example, if I'm going to give you a countdown, there's no such thing as negative seconds there. You get me? Or rather, if I'm going to what goes one? Uh, what's that? Not only countdown but also timer. I wanted to know the length of the duration of the movie. No, there's no negative. It should be positive. Okay, it should be positive as always. So therefore, in this case, it should be positive. So the answer for that is 1.89 seconds. Okay, so yeah, that's the answer. Now I told you, right, that's the first way. Now how about the second way? Second way is basically like what I call this one. What if you have what I call this one? You have negative as positive, and what if your downward is positive while the other, like going up, is negative? We can do that, okay? However, let's do it as fast as we can, okay? Now that you know the steps, okay, the steps are just the same. Start with the acceleration, get the solution, yada yada, okay? So second way, like what goes up is negative, what goes down is positive. Okay. So in that case, your acceleration is positive 32 feet per second squared. Now we solve for the velocity formula. So you will get dv all over dt is equals to positive 32. Disregard the units. Okay, the units. So put dt beside 32. Okay, here. Then we integrate them both sides. We will get v is equal to 32 t plus c. That's basically your general solution. Now, we need to find this particular solution by basing it on the initial scenario. Remember that your initial scenario, your t is always 0. Okay, so in this case, 0 seconds. Now, for your initial velocity, right? Remember, your initial velocity is 500 feet per second. And now I told you that, right, initially is 500 feet per second, and then it's dropping down. So here, in that case, uh, remember what goes down is positive. So we will use positive 500 feet per second instead. So we will get 500 is equal to 32 times 0 plus c. So your answer is C as 500 feet per second. So therefore, you have V is equal to 32T plus 500. So here, this is your particular solution. That is the formula for your velocity. Okay. Now, we're not done yet because we're looking for displacement, right? So we're going to change V as ds all over dt. So this is ds all over dt is equals to 32 plus 500. And you know the steps, okay? Put dt beside 32t plus 500, right, plus 500. Then integrate both sides. You will get s is equal to 16t squared plus 500t plus c. Then this is your general solution. Okay, this is your general solution. So you're going to what? Basing it on the initial condition or initial scenario for you to find a particular solution. Okay? So initially, your t is 0 seconds. And remember, you're the initial, like from the body is still at the top, and that means it hasn't achieved any displacement yet. So therefore, your s is 0. So in this case, what happened is that you will get 0 is equal to 16 times 0 squared plus 500 times 0 plus c. So all of them will result to 0, so your c is 0. Hence, your particular solution would be s is equal to 16t squared plus 500t. That's it. That is your particular solution. And now that you have found your formula for your displacement, which is 16t squared plus 500t, now we can use that in solving the problem, okay? Which is the time required for the body reach the ground, okay? So, right, this is the body reach the ground, so it reaches 1,000 feet. Now, does that mean your S is negative or positive? Since we changed the sign convention where going down is positive and going up is negative, so therefore here in this case, we will have what? Positive 1,000 feet. Okay? So therefore, your S would be 1,000. Okay? Then we solve for your T value. So here, we're just going to apply quadratic formula. I just transpose 1,000 to the right. You have 16t squared plus 500t plus 1,000. Okay. So wait, let me fix that here. Okay. That's it. Then here, you will use the formula. Okay. T is equal to negative b plus minus the square root of b squared minus 4 ac all over 2a. So here you will get t is equal to negative b, which is 500, plus minus the square root of b squared, which is 500 squared, minus 4 times a 16 times c 1,000. All right, that's it, all over 2 times 16. Now we will combine everything. So this is just negative 500 plus minus, wait, let me get to know the value here. Wait, guys. There's a correction. Wait, forgive me. There's a correction. Right? I transpose 1,000 to the right, right? So of course it's minus, not plus 1,000. Okay, so it's negative 1,000. I was wrong. I transpose 1,000 to the right. I forgot to change the sign. So therefore this is 1,000. Okay, negative 1,000. Forgive me. Okay. Okay, going back. So the value for that. Okay, so let me just pause this. Is this just the same as earlier, which is 314,000 all over 32? Then we can simplify this one. So here we will have t is equals to negative 500 plus minus 20 times the square root of 785 all over 32, in which if we simplify it one more time, this is just negative 125. plus minus 5, the square root of 785 all over 8. So here, again, you have two values, okay? So let me just copy this. One that is in plus 5, okay, which is this one, okay? Negative 125 plus, okay, plus 5 square root of 785. And the other, which is instead of plus, it's minus. Okay, instead of plus, we will get minus 5. So minus 5 square root of 785. Now let's take a look at their approximate values. For first value, you have approximately 1.89 seconds. On the other hand, okay, you have negative 33.14 seconds. Now you see the values here? They're just the same as what we found. Look at this one. Wait, this one. You see? Negative 13 negative 33.14 seconds, 1.89 seconds. Likewise, in this case, negative 33.14 seconds and 1.89 seconds. And of course, the answer is the positive one. So 1.89 seconds. That's the answer, okay? So now you know, guys, I showed you two ways on solving it. One, positive upward, negative downward, or the second way, positive downward, negative upward. All right. So now this is, you know, purely detailed explanation on how to solve this problem via differential equation. And I hope you have learned something in this video, guys. All right. Sorry to keep it in detail, but I have to because if not, you'll be having a hard time. So that is all, guys. See you soon.